Hi, welcome to McClelland Elementary. I'm Mrs. Heather Peacock, third grade teacher. We're here today for a great lesson with Mr. Crosslin on weather, wind, and ice.
Hey, thanks for that great introduction. And I'm with some exciting weather kids. We've been studying the weather the last couple lessons, and I don't know why, this lesson is on wind and ice, and we had a snowstorm just for our lesson. It's been snowing outside, hasn't it?
Yes.
But if you notice the snowstorm we had a couple days ago, there was no wind. And because there was no wind, it was beautiful. The flakes just came straight down. But as you've been studying weather, you know that the weather patterns change all the time. One day there's no snow, the next day there's snow. One day there's no wind, the next day there's lots of wind. So we see changes like that all the time. Now, here are two pictures, and we turn the lights out, maybe we can see these even better. Here are two pictures of what happens with wind and ice damage. Here is sometimes when wind will blow over a big tree, and this one, unfortunately, is what happens when we have an ice storm. But before we get into wind and ice, let's take a closer look at the weather right now. This is one of my favorite weather sites. You can put this on your Chromebook, and this is called Weather Underground, which is a weird word, but it's actually a great site. In fact, this is some of the temperatures right now. Let's click on full forecast and see what happens. Ready? This is our full forecast. Bring that up just a little bit. Right now, where we're at our school here, it is 6.6 degrees Fahrenheit. Is that a warm day? No, it's cold. And what I like about this, it even tells the sky conditions. Who can tell me what the sky conditions are? Clear. And do we have any wind today?
No.
Are you sure? Look.
Yes.
Oh.
Yes. 16.6.
16.6 miles per hour, but it gusts. Gust means it gets faster. And that's something we're going to learn about today. We're going to build, you are going to build a structure. After we learn a little bit more about wind and ice, you're going to build a structure, a tower. And then I'm going to use a fan to simulate a windstorm. And we're going to see if your structure, your tower, will stay or it will be destroyed by wind. So it's going to be kind of interesting. Are you interested in doing that?
Yes.
Okay, let's take a little closer. Let's go down a little bit down and look at this. This is our 10-day forecast. So here's today. And you see, why do you think these temperatures are in red and blue? What do you think? Yes, sir. What do you think that means?
The red one is hot, the blue one is cold.
So the red is the high temperature, and the other one is the low temperature. Do you notice that every day it gets hot and cold, hot and cold? Does anybody know what that might be? If you take a look at that, hot and cold, think about that. So I got my friend here. We're going to see why the temperature is high and low every day. Do you have any idea why you think it might be high and low every day?
Because when in the night the sun goes down, so it gets colder, and then in the daytime the sun comes up and it gets hotter.
You're absolutely right. In fact, would you go turn off the lights in the room here? Watch this. Hold your globe up right there, and the Earth rotates, and so let's rotate it that way. Can you spin it with one hand? There we go. Stop. Right now, the sun is over where? Anybody? United States, right? And as it rotates that way, rotate. Now the sun's over the ocean. More. Now who's having daytime? What do you think? China. So they're getting warm, and as we rotate more, United States is cold, but keep going, and now we're getting warm. So every day, as you see here, we have highs and lows, and the sun has a lot to do with it. Rotate again. At night it cools, the earth rotates. During the day it warms up. Wouldn't it be a terrible world if the earth did not rotate and this side was always very, very
Hot.
and that side was always very, very cold? That was a great answer of why we have highs and lows. Okay, so we have here the weather forecast for the entire month. Here's today. And you notice that it's sunny, and I look outside. Is it sunny outside?
Yes.
Yeah, they got this one right. That's good. This is a science that makes predictions. And when things change, the weather changes. So it could be sunshine, it could be clouds, it could be temperature, it could be precipitation. And I'm looking at when we expect, we expect some rain here and sunshine. And when's the next time you think it might snow, according to this? Yes, when?
On the 22nd.
Show us. On the 22nd. Who knows? Maybe next week, a Thursday, it'll snow, and that'd be really nice. Let's go down maybe a little bit more. Let's see what's going to happen the last couple days of the year. And it looks like, sunny, sunny, sunny. When you guys are off for Christmas, look at the expected temperatures. 51 to -2, that's the record. That's not what it's going to be. The record means that there was a time when it was 51 degrees on Christmas Day. And there was a time when it was -2 degrees on Christmas Day. So these are records and these are forecasts. What do you think it's going to be on Christmas Day? Well, think about that. Let's take a look at something else. All right, so we did a quick Google search on wind and ice and the damage it can do. I don't know if you've seen any of these. I've lived through a lot of these, but sometimes even in the forest, if you take a look at, click on this one right here, this picture, yeah, that one. After a windstorm or a big ice storm has come, the trees actually sometimes get bent over. A lot of times they'll survive and come back, but a big wind can do a lot of damage in a forest. This one is a big wind. I don't want that to happen in my yard, but look what happens when the wind blows and you have an old tree. Now usually trees are pretty strong, but if you get a lot of rain, it loosens the soil and you get a big wind, this could happen. In fact, if you look on some of these related images over here to the right, all of those are things that we don't want to happen in our house, but they could happen. Here's one thing that we really don't want to happen. Let's go down to the next picture. To the, yes, do that one right there first. This, I've seen this. When you guys were in kindergarten about 4 years ago, we had a big ice storm here in Indianapolis. And what happens is it rained way up in the sky. It was rain. But down on the ground, it was really cold. So as soon as the rain hit the bushes, look what they did. They froze, just like that movie. Let it go. No, we wish this weather would have gone. Check out these other pictures here. As the ice comes down, it gets heavier and heavier. In fact, it gets so heavy that everything is covered in maybe a half to 1 inch of ice. And ice is made of water, and water has mass. It takes up space. So it gets heavier and heavier and heavier. If you look up here to the top, that house right there, check this out. Your trees in your front yard, that could actually happen to them. It could actually get so heavy, they break down. And if we close that out, let's take a look at one more. So we have to design our buildings. Let's go on down. I think there's some that shows a bunch of traffic lights, and here we go. Look at this road right here. Now, you want to, look what happened here. That was just an ice storm where it got so heavy that all the branches fell, and it may look beautiful. It is beautiful to look at, but that breaks all the wires, electric, telephone, TV, cable, and it takes a long time to fix it. Check a look at this next one right here in the next. These trees get so heavy, they actually bend down. And now, some of them will come back, but in the summertime, when all those branches are broke, now insects can get in there and have an easy time eating parts of the trees because it breaks the branches. But I really want you to be careful. If this ever happens, check this one out down here in the bottom row. That one, that's dangerous. In fact, look at the wires on the top one over to the right. That's where we get into problems. It gets so heavy, it breaks down. So when you design your tower, we're going to add 4 cups. And guess what we're going to put in those cups? And in those 4 cups, we're not going to put water. We're going to put ice cubes. Ice cubes. It's going to make it heavier, and you'll see what will happen. All right, that's a little bit about ice. Let's check out wind. Okay, so let's take a look. I can't take these 2 great students out in a windstorm, or can I? So I'm going to bring the windstorm to them. Because wind is when things start. What's wrong, girls? Come closer. Can you get in? In fact, come here. Wind is when it gets pushed and people get pushed out of the way. Let's check this out. Hey, let's see what Bill Nye the Science Guy tells us about where wind comes from.
Bill Nye the Science Guy.
Wind all over the world is caused by heating and cooling of the earth. Wind can do work. Hey, look at that. And it makes sailboats go.
So one of the windiest places in the United States is a place called Mount Washington. It holds the record for the windiest places. Would you like to see it? Yes. Okay, check this out.
Top of Mount Washington, the summit, at 6,288 feet. We have a beautiful, beautiful sunrise this morning.
You'd expect that it's
This is the view.
windy on top of a mountain. In fact,
It's minus 18 degrees out. And we have about a 15-mile-an-hour wind, which actually right now I don't feel any wind. It's about 0. Watch this. Now watch how delicate this is. It doesn't go flying, blowing off the mountain. That is one serious snowdrift.
Wow.
The sun's peeking out. You can see, making for some nice pictures.
okay, so here's what you're going to do. Each team is going to get a tray like this and some tower building things like this. All right? I don't care how you make these. There's been all kinds of construction. But you're going to make a tower. You're going to have about 15 minutes, right? Your job. You can use some construction tape and put these together if you want. I don't know. Do you think it'd be a good idea to hook them together or not?
Yeah, good idea.
You think so?
It's gonna be like
I don't know. You might even hook them to the ground. That's going to be your job. The hardest part about this job is working together. You know what I mean?
yeah.
Okay, teamwork. You can make your tower high if you like. Really high if you like. But remember, the higher it goes, the more wind. That's going to be your job. Okay, I got this one going. Put a few more. But here's the deal. Once you get your tower high enough or strong enough, you're going to get four cups. 1, 2, 3, 4. So this would be your structure if it was just no wind. But we're going to add ice. Each red cup gets 2 ice cubes. And that's going to add extra what to it? Weight. So when an ice storm comes, it's not so much the ice, it's the weight. All right. We're ready to test this one. You guys want to make your own?
Yeah.
Okay.
I tried it.
Let's supposed to put this.
It's okay. Be careful, this might go down.
Two cubes per cup.
8, 7, 6, 5, 4, 3, 2, 1.
Now what I like about these towers is that they're all different, but let's see how they're going to stand some windstorms. Because we're going to start with a calm, and then we're going to go to a light breeze, then we might go to a fresh breeze, we're going to go to a moderate gale, a fresh gale, and maybe even a hurricane. Are you guys ready to test yours?
Yes!
Okay, I'm going to start this one 2 meters back. And can you see, this is a little bit of a breeze.
Do it a storm.
I see a little bit of rattling. Now I'm going to move it to a strong breeze. Maybe even a gale. Here comes a gale. I better go to a strong gale. Pretty good.
You guys
Pretty
did a
good.
nice job.
And let's go to a hurricane.
Oh, God.
Let's give him a round of applause. Nice job. Okay, I'm 2 meters away. A light breeze. Very good. Let's go a little bit closer to a strong breeze, a meter away. All right, let's go to a strong gale. Pretty good. And finally, let's go to a hurricane. And a few gusts. Nice job. Let's give them a round of applause. Here we go. From 2 meters away, a light breeze.
2 meters. Oh, that fell off.
Let's get to a little bit of a gale. Come closer.
What is a gale? Yes,
If you look on the chart up there, you see a gale is stronger. Let's go to a strong gale.
Yes, it's not going.
Oh. Here comes the hurricane.
Yes, not even a single ice fell.
Here's our next one. The lady engineers are very excited about this. Here's our breeze.
Ours is starting to fall.
Here comes a gale. I see some vibrations. Here comes a strong gale. Uh-oh. Doing pretty good. Here comes a hurricane.
Yeah.
Here we go. Here's a light breeze. I like how the reinforcement is on this one. Watch out for debris. Debris. And now if we go a little bit closer, a gale.
Not even a single thing.
And even closer, a strong gale. Wow, it's doing pretty good. Let's go a hurricane. Here we go. Light breeze. Oh, I have problems with this one. Light breeze, some damage. Here comes a gale. Strong gale. Hurricane. Now they decided not to use any tape. All right, next. Light breeze. Oh, we're in trouble. And even further. That one looked promising, but really. Okay, let's start with a light breeze. Let's move a little bit into a gale.
They got a lot of ice.
Let's go into a strong gale. Oh, and a hurricane.
I believe that when there's a weak house, then a strong wind came, it will just blow everything down to the ground. If we have a strong building, it will just stay there.
What happens when we get ice on that weak building?
It will be much stronger, but sometimes make it more weaker because the ice melts.
And it's heavier, and then it comes crashing down. Nice job. What did you learn?
I learned that ice can do a lot of damage to houses.
What did you learn?
I learned that wind can be really strong. It can like knock down a whole entire tower.
What did you learn?
I learned one way to make them strong is to add tape.
We had a great time learning about how wind and ice affect structures. We had a big wind and ice storm in our classroom. Some of our structures held up really nicely, and some might need some improvement the next time.